Okay, this short video is on gates, Boolean expressions, and truth tables. All right, so let me just start with a pretty simple example. Let's say we have an AND gate and an inverter. We put a variable A into here. We'll put B into here. And we'll take that output and put that together with an exclusive OR. And take the variable C and look at the output F. Okay, so this is a logic circuit. You can build this out of electronic components. And we would be able to write a Boolean expression for F. All right, so the way we would look at this is on the output of the inverter right here, I have a bar. We put a bar over a variable to imply that it's the complement of that variable. All right, and so on this gate, I have a bar at the input. So on the input side here, I have a bar and then I have B. So on the output, this would be a bar ANDed with B. All right, so notice I didn't put a symbol in there. It's an implied AND. All right, just like you have implied multiplication in regular algebra. All right, from there, these two guys are the inputs to the exclusive OR. All right, so F would then be A dot B. The symbol for exclusive OR is an OR symbol with a circle around it. Exclusive ORed with C. All right, so this is what we would call a Boolean expression. All right, and so this would be the answer if I asked you for a Boolean expression on an exam. All right, so I think that's pretty straightforward. Next, I want to talk about the idea of a truth table. Okay, so a truth table would mean that you take variables, the input variables, A, B, and C, and I wrote them in a certain order, a certain natural order. And it turns out that is important, and I'll show you why in just a second. Okay, so I'm going to make this table, and I'm going to put a halfway mark here. And I'm going to put all the combinations of these variables. So there's 3 variables, so there's 2 to the third combination. So 8 combinations. Okay, and so we write this down in this order, and I just want to show you this real quickly. If you take the A column here to be weighted by 2 to the second, and the B column to be weighted by 2 to the first, and the C column to be weighted by 2 to the 0, you can actually turn these variables into a binary number. All right, so for example, if I was looking at, say this row, all right, there's a 1 right here. So that would be 1 times 2 to the second. There's a 0 right here. So this would be plus 0 times 2 to the first. And there's a 1 here. So this would be plus 1 times 2 to the 0. All right, so this would end up being, 2 to the second is 4. And then this is 0, and 2 to the 0 is 1. So this would be represented by the decimal equivalent of the binary number 101 of 5. Okay, so a lot of times people will label a truth table as the decimal equivalent, and you notice it goes in this order of natural counting. Okay, so that's why it's important to get the variables in the right order, A, B, C instead of C, B, A or some other combination. On an exam, I would tell you the order. Okay. Now we want to finish off the truth table, so I'm going to have an intermediate step here. I'm not going to put F right away. I'm going to put down first, look at my logic expression. I would put down first the A bar ended with B. Okay, and so I can figure out the logic behind that. All right, the only way this A bar ended with B is going to be a 1 is if A is 0 and B is 1. Other places it's going to be 0. So I'm looking for when is A equals 0 and B equal 1. All right, so I see it here and here. I don't see it anywhere else. Only those two spots have A equals 0 and B equal 1. So that's where the 1s will be on this logic expression. Everywhere else, 0 for A, you invert that would be a 1. 1 ended with 0 is 0. So that's the case for all the other combinations. Okay. Next, the output F is then just the exclusive OR, all right, of A bar B exclusive ORed with C. All right, so we're looking at an exclusive OR, and so I care about now the C column and the A bar B column. All right, so it's exclusive OR on that column. So that means it can be one of these a 1, one side of the column is a 1, and the other column has to be a 0. They can't both be 1. That's what exclusive OR means. All right, so if I look at that, I can write down the exclusive OR. That would be F here. So 0, 1 exclusive OR with 0 is 1, 1. But we have two 1s here, so that would be a 0. 0, 1, 0, 1. All right, so that completes the truth table for this logic expression. All right, so there's a little short video about gates, Boolean expressions, and truth tables.